Welcome to the channel So-Called Engineer. Today I discuss a small portion but most important portion of atomic and molecular structure, that is Schrodinger equation. Schrodinger equation. This is time independent Schrodinger equation. Here H cap is called Hamiltonian operator and E is constant energy where psi is amplitude. Now I discuss the derivation of this equation. First we talk about standing wave. Standing wave, it happens between two fixed points. This is a point and this is another point. If reflects the wave this way, then total amplitude being 0. Then this is the coordinate of x-axis, this is the coordinate of y-axis or amplitude axis or psi axis, and this is the maximum amplitude capital A, and from this to point this is called lambda, is wavelength. So from this wave we get psi x is equals to a sine 2 pi by lambda into x. This is a equation of wave function. This is a wave function equation. Wave function equation. So psi equals to psi of x equals to a sine 2 pi by lambda into x is a wave function equation. Now if we derive derivative the psi with respect to x, then we get d dx of psi is equals to 2 pi by lambda a cos 2 pi by lambda into x. Again we differentiate with respect to x, then we get this minus 4 pi square by lambda square into a sine 2 pi lambda into x. This is equals to psi, and we can get minus this into psi. So we get this. Now from de Broglie equation, we get lambda equals to h by p, where lambda is wavelength, p is momentum, h is constant. Okay, de Broglie constant. Then this equation 1, put the name equation 1, then put the value of lambda h by p in the equation 1, then equation 1 become d2 psi by dx2 minus 4 pi square by h square into p square psi. Now we can write this way, this is to h cut by d2 psi by dx2. H cut equals to h by 2 pi. So we write h cut instead of h by 2 pi. Now dividing 2m both sides, then we get p square psi by 2m equals to minus h cut by 2m d2 psi by dx2. This is kinetic energy. We know that kinetic energy is equals to total energy minus potential energy. Actual total energy equals to kinetic energy plus potential energy. So kinetic energy equals to total energy minus potential energy. So E minus V. Instead of kinetic energy, we put the value of this E minus V. Now E minus V into psi is equal to minus h cut square by 2m d2 psi by dx2. Again write this way, minus h cut square by 2m d2 psi by dx2 plus v psi is equals to e psi. This total is kinetic energy and this is potential energy. So write kinetic energy plus potential energy into psi is equals to e psi. So this is nothing but Hamiltonian operator. Mathematically, this equation is also called eigenvalue equation. Eigenvalue equation, where this E means constant E has the energy dimension for Hamiltonian operator. This is similar to eigenvalue equation, so it also called eigenvalue equation. Eigenvalue equation means this is a example of eigenvalue equation where A has same dimension for A cap. Okay, so we derive the Schrodinger equation. Now there are special case, that is particle in on dimensional box, particle in on dimensional box. This is a special case of Schrodinger equation. Let's draw a box. This is a box. Here potential energy is infinite. Here potential energy is infinite. Here x equal to 0. Here x equals to L. Its total length is L. Inside the box potential energy is 0. This is a special case where inside the box total potential energy is equal to 0. So now h card by 2m d2 psi by dx2 plus v psi equal to e psi. This is equation of Schrodinger. Inside the box v is 0. Then is inside the box potential energy equal to 0. Then equation become h cut by 2m d2 psi by dx2 is equal to e psi. Okay, again we can write e psi d2 psi, so d2 psi by dx2 plus k square psi is equal to 0, where k is equals to 2, k square is equals to 2m capital E by h cut square. Now this is a standard equation of wave, standard wave equation. Okay, now solve for the solution. There are boundary equation. First, psi of x equals to, let psi of x equals to a cos kx plus b sin kx, where a and b are arbitrary constant. Okay, a and b are arbitrary constant. Now when x equal to 0, then psi of 0 is 0, So put the value in equation, in this equation put the value psi x equals to 0, then we get a equal to 0. Okay, now again psi of L equal to 0, then we get b sine kl equal to 0, where b is constant, so b not equal to 0, then sine kl equal to 0, then we get kl equals to n pi and k equals to n pi by L. Okay, k equals to get this. Now we know k equals to 2 m e, k square equals to, note this, so n square into pi square by L. Again we can write this n square pi square by L is equals to, instead of h cut we put h by 2 pi, then we get 2m capital E by h square into 4 pi square cancel out, we get E equals to n square h square by 8m L square. This is our equation of energy. So we get the equation of energy inside the box. Now psi x equals to sine bx, because b sine kx, sorry, because a is equals to 0, so psi of x b sine, instead k we put n pi by L, n pi by L into x. This is the equation. Okay, now from the beginning of the lecture, you think that this function means this function, this is a function which oscillating, that's means particle is oscillating. From this equation we can tell that this particle is oscillating. That's not true. So then Max Born suggested that psi x into psi x equals to psi square x, interval dx, this dx means psi square x dx gives the probability, of the system in the interval x and x plus dx. So total probability is varies 0 to L, limit varies 0 to L, psi square dx is equals to total probability equals to 1. From here b square 0 to L sine square n pi L x equal to 1, or b equals to get root over 2 pi. Integrating this part we get b equals to this. So to final equation is this. So this is equation, Schrodinger equation for a special case, that is particle in a box. Schrodinger equation of a particle in a box.